students, this is Unit 4, Similarity. Lesson 4.1, Proportions and Similarity. Here's your new calendar. If you look closely, this calendar takes you all the way to Christmas time. That should make you happy. How to use this packet. Make sure you follow all the instructions given in the video. When you're told to pause and work on your own, actually pause and work. Then check your work. Always both watch and listen and follow. Do not just copy. When you're finished, you should take 2 minutes and verbally review the content of the lesson. Talk yourself through the contents. Remember to get your notes signed off by your parents or guardian affirming your efforts. Keep in mind, students, if you don't wish to watch these videos in order to learn the content, you are always welcome to come by and do these lessons in person with me during optional second, if you have it, lunch or after school, as long as it's done prior to the due date. Remember to record the where you are watching this video, as well as the date and time. And get a parent signature sign-off. We're going to do a quick review. You've been given the endpoint of a segment and its midpoint. I want you to find the other endpoint. So let's graph what you have. We'll give you a minute to solve and see if you can't do this on your own. So we have an endpoint 4 of a segment. This is an endpoint. We have a midpoint of -8, +5. So -8, +5. This is a midpoint. Your goal is to find the other endpoint. And keep in mind, if this is a midpoint, that means your endpoint is going to be off the grid. So you need to think about this logically. Your other endpoint is over here somewhere. Take a minute, do what you can to figure out the other endpoint.
All right, you should have noticed here that when we go from 4 to 5, there's only a 1-unit difference. And we're technically going 1 up from 4 to 5. That's vertical. That means whatever your coordinate here is for the y-coordinate, it's also 1 up as well. So this is going to be 6. From here, from +4 to -8, that's going to be down 12. So you have to go down 12 here. So if -8, if you march 12 units this way, it's -20. So your coordinate, your exact midpoint, is going to be -20, 6. All right, we're going to be dealing something that's very common. You're actually quite familiar with this concept. You maybe just have a new vocabulary here. We're going to be dealing with a concept called ratios and similarity. Ratios and similarity. Vocabulary you need to be familiar with by the end of this lesson is the concept of a ratio, a proportion, the concept of similar, scale factor, the extremes, and the means. A ratio is simply a comparison of two factors by division. It's a comparison by two factors of division. So ratios, all ratios involve the concept of division. And since we're dealing with a comparison, when working with units, such as centimeters, meters, feet, and yards, because we're comparing units, you need to compare what's called apples to apples. You can't compare apples to oranges. You have to compare alike kinds of things. So you must always get into the same unit before you can make a ratio. Take a look into your reference booklet. One of the very first pages is an entire front and back page which has nothing but units, conversion of metric units and English units. You need to be familiar with that page. Now, ratios that you're familiar with. You're familiar with ratios as using the word to. You're also familiar with ratios in a colon, a fraction, and a decimal. Let me give you an example. For example, 3 to 4 is a ratio. Expressed as a colon, it would be 3 to 4 using a colon. As a fraction, it would be 3/4. And as a decimal, just think 3/4 of $1. Most of you are able to think in money quite well. 3/4 of $1 would be 75 cents. These are all ratios. They're just different ways of expressing them. A proportion is an equation of ratios. So a ratio is simply something over something. If we have an equation of ratios, it's something over something equals something over something. So right here, this individual fraction would be a ratio. This entire equation of two ratios is a proportion. Now, when you work with proportions, there's some terminology you need to be familiar with. Ready? Let me give you an example. Let's use our 3/4 example. So 3/4, and then an example of 3/4 would be 6 over 8. Because 6 over 8 reduces to 3/4. So we can say we have equivalent ratios here. That's a ratio. This is a proportion. All right, so you guys are familiar. This is a true statement. 3/4 does equal 6 over 8. Now let's order these terms from least to greatest. The least would be 3, the greatest would be 8, and the middle terms would be 4 and 6. Now, those middle terms are called the means. Think means, middle, means, middle. These end terms, these are called the extremes. Think extreme beginning and extreme end. So in this case, the product of the means, we're going to go 4 times 6, multiply that, write that number out. You've got 10 seconds. Should have gotten 24. Now let's multiply the extremes. Got 10 seconds. Should also get 24. So look what happens here. When you have a proportion, the product of the extremes equals the product of the means. Lo and behold, you guys are already familiar with this. This is called cross multiplication or cross products. So we're going to use the concept of proportions in order to make some problem ratios. It says Shauna drove 240 miles and used 8.2 gallons of gas. So for every 245 miles, she used 8.2 gallons of gas. At the same rate, if she drove 416 miles, so we put miles on top to begin with, so we go 416, how many gallons of gas will she need? So to X gallons. So we're making a comparison by a ratio. The product of the means equals the product of the extremes. So we're going to cross multiply here. Resist the temptation to instantly use a calculator. Ready? We're going to go 8.2 times 416 equals 245 times X. Take the hands off the calculator. Our goal is to get X by itself. So we're going to divide both sides by 245. So we're going to get X equals 8.2 times 416 over 245. Once you have your unknown isolated, now you may get a calculator. Do not touch a calculator until your unknown is completely isolated. So now we can do 8.2 times 416 divided by 245. And we get 13.9 gallons. 13.9 gallons. Let's try another one. It says, Trish needed 3 feet of Velcro for every 2 yards of fabric purchased to make a table banner. What is the ratio of Velcro compared to fabric? So we're going to go from comparing by division Velcro to the amount of fabric needed. Okay, watch very carefully. Your first instinct is going to be, for many of you, to do this. Oh, I see Velcro, it's 3. And let's see, fabric, I see a 2 here for fabric. So my ratio must be 3 to 2. That's many of your first instincts. If you do that, you're going to be dead wrong. because there's a change in units. You must get into a like units before you can make a ratio. Watch carefully. Carry your units over. Velcro is 3 feet to the fabric, which is 2 yards. Notice the change in units. You cannot make a true ratio comparison until you get in the same units. That's why there's this page right here, because if you don't know what the feet to yards conversion is, you're going to need to look at this page. Now, if you look in this page, you know that for every yard, linear yard, there is 3 feet. So I'm going to get into the same units. So I'm going to go 3 feet, and 2 yards is going to be 2 times 3, so this is 6 feet. Now that you're in the same units, now you can make your ratio. It is a 1 to 2 ratio. I want you to pause the video, do this page, and restart the video when you're done to compare. All right, welcome back. Hopefully you actually paused the video, did your own work, and then returned. It says right here, 3 is to an unknown what 18 is to 24. We're going to cross multiply. Resist the temptation to immediately use a calculator. We have 18 times x equals 3 to 24. The key to multiplying is not multiplying. Watch carefully. Notice I'm not multiplying 3 times 24. Watch what I do. Your goal is to get x all by itself. So I'm going to divide by 18. So I have x equals 3 times 24 over 18. Take your hands off the calculator. Learn to not multiply but factor instead. I know that 3 goes into 18 6 times. Then I also know that 6 goes into 24 4 times. So my answer here to x is 4. And I didn't even have to touch a calculator. Let's try another one. Says 2, whoops, number 2. Watch out for a change in units here. We're going to write in simple form fraction. We're going to go 44 centimeters over 2 meters. Now, your temptation will end up to be doing this, 22 over 1. Again, you would be wrong because there's a change in units here. This 2 meters, you have to get it in a like kind. So 44 centimeters for every 1 meter, that's 100 centimeters. Centi, same prefix as century. So 2 meters is actually 200 centimeters. Now that you're in the same unit, now we're going to reduce 44 to 200. 4 goes in here 11 times. 4 goes in here 50 times. So your actual simple form ratio is 11 over 50. This one, 2 supplementary angles have a ratio of 3 to 2. Find the measure of the angles. Supplementary means 180. So I have 2 angles. that add up to 180, and they have a ratio of 3 to 2. So what that is exactly saying is it's 3 of something and 2 of something. And that reduces to 3 to 2. So to solve, I'm going to go 3 of something plus 2 of something equals 180. It's 5 of something equals 180. Divide by 5. Take your hands off the calculator. Look, Mom, no calculator. 5 goes in there 3 times. That's 15. Bring down the 3 and a 0. 5 goes into there 6 times. So x equals 36. Then you do 2 times 36. You get 72. Then 3 times 36 is 108. So the actual angle measure is going to be 108 to 72. Solving proportions using variables. You cross multiply. Always, 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 always draw your cross multiplication arrows. Next, always. Never, 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 never distribute in your head. So always draw cross multiplication arrows and never distribute in your head. Notice I'm writing it out. You should have solved. And why? You should have gotten negative 21. Now that you're comfortable using proportions, now we're going to get into the concept of similarity. Now, similarity, honestly, you're familiar with it already. Similarity is a very easy concept. Every single time you go shopping, you are dealing with the concept of similarity. Similarity is simply going to talk about items which are the same shape, but a different size. Same shape, different size. The most common form of similarity that you are going to come across is the idea of clothing. We have small, medium, and large. Although they're different sizes, the shape of the shirt is the same. So the shape remains the same, still a short sleeve shirt with the same proportions, but the sizes will be different. Same shape, different size. That is the concept of similarity. The symbol we use for this, when things are exactly the same, we say they're congruent, and that's the symbol for congruency. For similarity, we use this one little squiggle. That means same shape, different size. Now, same shape, different size, that is what I call the common form definition, common. It's a simple form, it's easy to remember. Similarity means same shape, different size. But similarity has a geometric definition. And we're going to use the acronym SCARE. When something is similar, remember SCARE. Similar shapes have congruent angles and side ratios which are equal. Similar shapes have congruent angles and side ratios which are equal. Similar shapes have congruent angles and side ratios which are equal. Similar shapes have congruent angles and side ratios which are equal. Similar shapes have congruent angles and side ratios which are equal. That is what we call scale. Let me show you what I mean. These two shapes here on the left are similar. You can see that they have congruent angles. Congruent angles. These angles match. These angles match. Corresponding angles match. So corresponding congruent angles. So that's the congruent angles. Next, let's check the side ratios. Ready? 4 to 8. Reduce that. That's a 1 to 2 ratio. Let's try another one. 6 to 12. Reduce that. That's a 1 to 2 ratio. 2.8 to 5.6. Don't let that decimal scare you. If you think 28, you times by 2, you get 56. So 2.8 doubled is 5.6. Again, it's a 1 to 2 ratio. This side, 2.8, 5.6. Again, a 1 to 2 ratio. So these shapes are similar. They have congruent angles and ratios which are equal. When shapes are similar, you're going to have something called a scale factor. The scale factor is simply the ratio of the sides. It is the side to side ratio. So side over side or side to side using a colon. And that is called scale factor. So taking a look here, let's find a scale factor of these shapes. 45, and then we find the same position to 9. Let's check here. Short end, 15 to 3. Let's reduce both of those and make sure they work. 45 to 9. 9 goes into 45 5 times, so this is a 1 to 5 ratio. 3 to 15, 3 goes into 15 5 times. So we would say our scale factor, if we go top to bottom, is 5 to 1, top to bottom. Or if we go bottom top, it's going to be 1 to 5. That's called scale factor. Scale factor is the reduction of the sides. So we're going to determine if the shapes are similar. We're going to use scale. Remember, scale means congruent, angles, ratios, which are equal. That's what similar means. So let's check our angles first. Congruent angles. Well, it's easy to tell if the angles are equal because they're all right angles. So all we have to do is check side ratios. So I'm going to go long side to long side, and I can instantly see that this from here is a 1 to 2 ratio. Then I'm going to check short to short, and we get 5 to 8. That is not a 1 to 2 ratio. It does not reduce 1 to 2. So these guys are not similar. Although they have congruent angles, they do not have equal ratios. Now, here's something you can do. If things are similar, when ratios are equal, Then the sides are proportional. Remember, proportional means something over something equals something over something. So, for example, the images below are similar. Put the little similarity sign. Remember, similarity means we have congruent angles, ratios which are equal. So first off, we're going to find our scale factor. We're going to go from left to right, 9 to 6. That's left to right, trace. And our scale factor, 3 goes into 9 3 times, 3 goes into 6 twice. So our scale factor from left to right is going to be 3 to 2. Or you can write 3 over 2. Now we're going to use this proportion to find our missing side. If we start left to right, we must finish left to right. So I'm going to make a ratio left to right. Ready? Watch this ratio. 3 to 2, that's our scale factor, equals 21 over unknown. Resist the temptation to use a calculator. You cross multiply, we get x by itself. Remember, always draw your cross multiplication arrows. 3 2x equals 2 to 21. Notice I'm not actually multiplying. The key to multiplying is not to multiply, but to factor. I'm going to divide both sides by 3. Notice I'm still not multiplying. So I'm going to get x equals 2 times 21 over 3. Now, we can reduce. 3 goes into 21 7 times. 2 times 7, x here is 14. Let me give you another example. It says find the variable and the side length, knowing the shapes are similar. So we know the shapes are similar. Now, where you're given a scale factor of A to B. So, right, I'm going to color code this for you. A to B. So we're going to go from A to B. And our scale factor is A to B 3. So it's a 2 to 3 ratio. And on that note, let's start solving. Now we can do left to right. That's going to be 14 to 7 plus x. So 14, that's my A side. 7 plus x, that's my B side. I can do this because they are similar. From here, you're going to solve for x. Draw your cross multiplication arrows. We get 3 times 14 equals 2, parentheses, 7 plus x. We're going to get 3 times 14 equals 14 plus 2x. 3 times 14, we know that's 12, carry the 1. 3 times 1 is 3, plus 1, that's 42. So this is 42 equals 14 plus 2x. We're going to minus 14. We get 28 equals 2x. We get x equals 14. Now, if you're really on top of it, you can actually come up here and check your proportion. 2 over 3 equals 14 over 7 plus 14. It's going to be 2 over 3 equals 14 over 21. And if you reduce, 7 goes into 14 twice, 7 goes into 21 3 times, and you see the proportions match. You try this stage on your own. Stop the video, restart when you're finished, and check. We're given that the shapes are similar. We're going to find the scale factor of smaller to larger. So keep in mind for each time we're going to go small to large. So ready? Small to large. Now watch the sides. Be really, really careful. We have to match congruent sides here, or similar sides. Notice this 49 here is at an angle, slight angle. That means you match it with 21, not the 20.7. So small to large. Let me keep my color coding correct here. My small is blue, my large is red. So small to large. My small is 21, my large was 49. 7 goes into 21 3 times. 7 goes into 49 7 times. So my scale factor is 3 to 7. That's small to large. Let's take a look over here. Again, we're going to go small to large. And you have to find corresponding sides. So I'm going to go with my long side here, which is 72. I'm going to match it up with my long side here, which is 84. So I do 72 to 84. Now I'm going to reduce. I know 2 goes into 72 36 times. And 2 goes into 84 42 times. I'm going to reduce again. 6 goes into 36 6 times. 6 goes into 42 7 times. So my actual ratio, my smallest ratio, is going to be 6 to 7. These are called scale factor. Here we can determine whether or not things are similar by checking for congruent angles and then checking for ratios equal. Ready? Okay, in this first one we can see that we already have congruent angles. See the angles match? We're going the same way. So we have congruent angles. Now let's check our ratios. 12 to 4. That's a 3 to 1 ratio. 18 to 6. That's a 3 to 1 ratio. 6.9 to 2.3. That's a 3 to 1 ratio. So this first one is yes, they are similar. Let's check this one. Our angles are congruent. Let's check our ratios. 4 to 6. That's a 2 to 3 ratio. And then we go 6 to 12. That's a 1 to 2 ratio. Whoops. Look, the ratios don't match. So we can instantly say not similar. Let's check this one. The angles are congruent, matching. Let's check the ratios. 12 to 8. 4 goes in here twice. 4 goes in here 3 times. 16 to 24. 8 goes in here twice. 8 goes in here 3 times. 12.2 to 18.3. 6.1 goes in here twice, and 6.1 goes in here 3 times. So it's a 3-to-2 ratio all the way around. Yes, they are similar. Following images are similar. Solve for the unknown. So here we're going to go from A to B, 2 to 3. So 2 over 3 is going to be x plus 3 over 21. Cross multiply. We get 2 times 21 equals 3 times x plus 3. Here's a little trick. Rather than distribute that 3, we're just going to multiply it straight out. And not multiply, excuse me, divide. Cancel it out. Over here, 3 goes into 21 7 times. So I am going to have 14 equals x plus 3. And you should have x equals 11. And you can plug that in to check. If you put 11 in here, 11 plus 3 is 14, and 14 to 21 reduces to a 2-to-3 ratio. So there's your check. Let's check up here. We're going to go from A, watch it, we're changing here, to B. So our A here to B, this time we switched from right to left. So our A is 3, our B is 7, and our A here in real life is 36, and our B going this way is 3x plus 27. Cross multiply. We have 7 times 36 equals 3 times 3x plus 27. Again, rather than distribute that 3, I'm just going to divide it out. Over here, 3 goes into 36 12 times. I'm going to do 7 times 12. 14, carry the 1, 84. Why aren't you using a calculator this way? It's good for the brain to do it by hand. So I have 57 equals 3x. Divide by 3. And you should end up with x equals 19. Come up here, we can check. X equals 19. Let's see if that actually works. 3 times 19. Is 57 plus 27. That's going to be 84 to 36. And if you reduce that, 12 goes in here 3 times, and 12 goes in here 7 times. That is a 3 to 7 ratio from A to B.